In today's lesson, we are, again, finding the area between curves. The last lesson, it was with respect to x, and this time it's with respect to y. And it's good to understand both because depending on the situation, sometimes it's easier to look at your graphs with respect to y than it is with respect to x, and vice versa. It's just good to know both ways. You kind of look at it from both angles and then decide which one might be easier to do. So for the first example, don't write anything down yet. I'm just going to review kind of last lesson quick. We were looking at, okay, it intersects at this x value and this x value. And then this is that upper one. That would be like our f of x. And then this is the lower one, g of x. So we would be doing that f of x minus g of x when we're doing the integral. And we're finding this area. But now let's think about this with respect to the y-axis. So we're finding the same intersection points here and here, but instead of x values, we're looking at y values. Where do they intersect? And then instead of thinking top bound, lower bound, you want to think the far right bound would be our f of x, and then the left bound would be our g of x. So it's still the same idea. We have this integral f of x minus g of x. And then I guess we should be changing these. So the idea is we're also going to alter our equations so they are solved for x. They're x in terms of y. So the first thing I'm going to do is let's solve these for x. So for the first one, I'm just going to cube both sides. X equals y cubed. And then the other one, that one's really easy, just x equals y. Okay, so the intersection points are, this is at the y value 0, and then this one is at the y value 1. So the integral is from 0 to 1, and then we're going to subtract, so this right function is this one, so y, minus the left function, this one, y cubed, and that is dy. So to find this area, let's take the antiderivative, y squared over 2 minus y to the 4th over 4, and from 0 to 1. So if you plug in 1, we've got 1/2 minus 1/4. If you plug in 0, we're just going to get 0. So this is a really nice, easy one, and you'll just get 1/4. Okay, here's another example similar to the last one. We're not going to fully solve it. We're just going to show the integral with respect to x and with respect to y. So with respect to x, we'll do first because they're already solved, y with respect to x. Okay, so intersection points, an x value 0, and then here the y, or the x value 1. So the integral is from 0 to 1, and it's the top bound, x, minus the lower bound, which is x cubed with respect to x. And then now let's do with respect to y. So we're going to have to solve these for y, or solve these for x. X equals the cube root of y. And then this one, x equals y. Okay, so now we're looking at intersection on the y values, 0 and 1. So that's the same, 0 to 1. But this time it's the right function, which is the cube root of y, minus the left one, which is just y, dy. So sometimes you could set up both of them and just think about, well, which one has the easier antiderivative? In this case, I would say with respect to x is the easier antiderivative, so you would solve it this way. But vice versa, it could be, your next example, it might be an easier antiderivative with respect to y. So you can kind of make those decisions sometimes. Okay, and here's the last example. This is a calculator active example. So y equals 1 minus x squared, y equals the square root of x minus 1, and y equals negative the square root of x minus 1. So the first thing you can do is graph your functions. So here's all three of them. And now next step, we can kind of make a choice. We can either change all of these equations, solve them for x, or we can find these intersection points here and here. And we're going to find this area, bounded area with respect to y. So we're looking at y values. So let's just look at these intersection points. So we've got 0, 2. This one, it's hard to tell exactly. So if you have a graphing calculator, you just find that intersection point, and I will give it to you that y is negative 2.35321. Okay, so now let's go solve these for x. So y minus 1 equals negative x squared. Negative y plus 1 equals x squared. So x equals plus or minus the square root of 1 minus y. All right, and then this one, y plus 1 equals the square root of x. Square both sides. So x equals y plus 1 squared. And then if we solve this one, y plus 1 equals negative square root of x. Negative y minus 1 equals square root of x. And then if you think about taking out a negative 1 before we square it, so now you square both sides. So notice how these two come together as the same equation when you are solving for x. And then this one, we will only need to use the positive 1 minus y, because essentially we're using the right side of this graph. So kind of confusing because this started as two separate equations, but when we solve them for x, it's like you can think of these together as one. And then this one represents this red one here. So the red one is the far right one. So we'll be doing this red one minus this blue one, the left one. So the integral is from negative 2.35321 to 0, and it's of the square root of 1 minus y minus y plus 1 squared dy. And then we're going to use this on just the Math 9 button on our graphing calculators. And when you're on your calculator, just ignore the fact that these are all y's, and you're really just going to be typing them in as an x. And when you do that on your calculator, you should get about 2.2675. So there's the last example. There's your full video on finding the area between curves with respect to y. Good luck with the lesson.